Okay, statistical inference uses sample data to draw conclusions about a population. So this is why it's really important that we do a good job of pulling a sample and getting a random sample. So one of the questions you want to ask when you're doing research is, what sample size do I need? Or more specifically, can a relatively small sample give us really accurate results, or at least fairly accurate, compared to the information we would get from a census? So a census would give us a good population parameter, but that's a lot of work and a lot of money. So can I get away with doing a small sample and still get pretty accurate results? So it turns out that the answer is yes, and that statisticians have proven this. And we're going to actually talk about what is meant by a small sample size and how much you need in order to do that. Okay, so even though X bar, our sample mean, is rarely exactly right, it's still going to be fairly close. And as you saw in the law of large numbers video, the more and more samples, or the larger our sample size, the closer we're going to get to our population mean mu. So our true mean is often how that's referred to. Okay, the law of large numbers holds for any population. It doesn't have to just be a normal distribution or a uniform distribution. It's going to hold for any population that we're looking at. We're going to talk about that more in some of our future videos. All right, so I want to review the law of large numbers again. It's a really important part of statistics. Okay, so again, the law of large numbers is the more trials, or the larger the sample size, the closer our sample mean is going to get to our population mean. So think about if I flip a coin 10 times, okay, and I get 4 heads, that's 40% heads, right? So my average heads would be 40%. 4 heads out of 10 doesn't seem bad, but that's not close to what I would expect the coin to be. My theoretical probability would be 50-50. If I did 1,000 coin flips and I only got 400 heads, that 40% again, that would seem really weird to me. I would think that there was something going on with that coin, that you guys gave me a shady coin here, right? So if I did 1,000 coin flips, I'm going to expect that to be a lot closer to the 500. It's not going to be exactly 500, but it's going to be pretty close. Okay, if I did 1,000,000 coin flips, it's going to be even closer, right? So more and more and more, it's going to get closer. It may not ever be exact, but it will get closer. So the law of large numbers is the foundation for businesses like gambling casinos, as well as insurance companies. And it is the backbone of something called actuarial science, which is the field of statistics and mathematics. And we actually offer some classes for that here. We've had several students take and pass some of the actuarial exams. It's actually a really interesting field to be in. So let's take a look at an example from your classwork. This is on the bottom of the first page, and it's on insurance. So it says the idea of insurance is that we all face risks that are unlikely but carry high cost. Think of a fire or flood destroying your apartment. Insurance spreads the risk. We all pay a small amount, and the insurance policy pays a large amount to those few of us whose apartments are damaged. An insurance company looks at the records for millions of apartment owners and sees that the mean loss from apartment damage in a year is mu is equal to $125 per person. So in other words, the population parameter, the average or the mean loss, is $125 per person. Most of us have no loss, but a few people lose most of their possessions. So that 125 is that average. The company plans to sell renters insurance for $125 plus enough to cover its costs and profit. So maybe they're going to charge $150 per person to cover their overhead and a little bit of profit to give back to their shareholders, something like that. So I'd like you to pause the video and maybe think about these 2 questions, jot down an answer if you can, but here are the 2 questions I want you to think about for a minute. So explain why it would be unwise to only sell 12 policies, and then explain why selling thousands of policies would be a safe business practice. So go ahead and pause the video for a second. Maybe think about that. If you have an idea, jot it down, and then we'll come back and talk about that. Okay, so selling 12 policies, let's put this in an example that maybe might make a little bit of sense and might relate to you personally. So last semester, Moffett Hall flooded, right? And everybody had to move out of Moffett Hall. I feel so bad for you guys that lived in Moffett Hall, because I think everybody lost a lot of stuff, right? So if I owned an insurance company, I'd only sold policies to people in Moffett Hall, and I had to reimburse you for all your belongings, and I only charged you the $150, my business would go under, right? I would have to declare bankruptcy because I only charged you $150 and there's no way I could replace all of your belongings with the money that I collected. Okay. If instead, as an insurance company, I had sold policies to everybody on Western, hopefully, if I'd sold policies to everybody at Western, I would have enough to replace all of your belongings, assuming that nobody else had run into any problems, right? Nobody else had damaged stuff. What would be even safer would be is if I sold insurance policies to all university students across the state of Colorado. Okay, so then if I'd sold policies to everybody across the state of Colorado and Moffett Hall was the only hall that flooded and had damage, then I would have plenty of money to cover your expenses to replace your belongings in Moffett Hall. And then next year I collect everybody's $150 again. And if something happened in another dorm building, maybe at CU Boulder or something like that, then the money that I collected I would use to replace their belongings. Right, so the idea is that hopefully nobody ever has to suffer this kind of loss, right? But the idea is that not everybody suffers the loss at the same time. And so it kind of goes around, right? And so the idea is that by selling lots and lots and lots of policies, you've spread the risk out. And so you are not having to pay all of the people in your policy group at the same time. You're just paying a few people out at a time. And so hopefully you're bringing enough money to cover the money that's going out. And that's what an actuarial scientist does, is they help you to figure out how much to charge so that you make sure you have enough to cover the money going back out.